So D equal to this. That gave me the wrong answer. But this problem, if we solve it in the usual way, we start from here. So 100 by 50 into 50, this gives me 100. So 100. So D is changed to 100. It was 100 previously also. So after this, 100 by 5 into 100, right? So sorry, 5 times 100 is 20. 20 gives times 5 is 100. Now D again remains the same. 100 by 10 into 10 gives me 100, and D remains the same. And now finally, when this comes here, 100 by 11 into 11 gives me 99. So on this tells me the day I should start my journey to finish under 100 days and still reach my destination as late as possible, if I start my journey as late as possible. Now if we go from this direction to this direction, this gives me on which day should I start on the first bus, which day should I board the first bus, so that I reach my destination as late as possible. But if you closely see, on the 99th day I'll board the bus A. On the 100th day I'll board the bus C. On the 100th day I'll board the bus B and C, and on the 100th day I'll board the bus D as well. So it was given in the question problem statement that we can board multiple buses on the same day. So on 99th day I will board the bus A, and B, C and D I'll board all these buses I'll board on the 100th day. But if you closely see, this also gives me the answer on which day should I start my journey so that I can reach my initial destination as soon as possible. And the simple answer would be board all these buses on the 100th day and wait for one day and board the last bus on the 99th day. So there are two ways we can see this problem. Start a journey as late as possible to reach my last checkpoint, or start my journey as soon as possible to reach my first checkpoint. So you get the point, right? What I'm trying to say. So I hope you got you got to understand the crux of the problem. The main thing that we had to think about in this question was that how many times is the bus coming at a particular bus station in a span of D days, and at what day should we board the bus so that we can start a journey as late as possible and still finish our journey under D days. Okay, so this was actually the problem. uh, Actually the video is getting very long, so I'll just tell you the code for this. You can try to implement it on your compiler. Okay, so first you have to run your loop from n-1 to 0. Okay, n-1 to 0, I minus minus. Okay, after that you have to take a variable d, and d contains the number of days in which we should complete our journey. So d will get updated every time in this loop. So we'll apply the formula d by x of I multiply by x of I. But first we should solve this, then we should multiply by this. And after this whole thing gets solved, after the whole thing gets solved, just return d. And by this you'll get the latest day possible so that you can start your journey and still finish your journey under D days. I hope this was helpful. If you have any doubts, just write it in the comment section. I tried my best to explain this problem. I've seen other videos also. They've used some other algorithms, but actually this is the best to solve this. They've used some binary search and all, and I think uh, if you try to focus on the crux of the problem, you'll be able to understand the problem. Okay, so thank you guys, and bye.